number 3. I have my rock. Center of mass. What forces are on it? Force of weight. Pulling straight down. What other forces are on there? Good, done. That's right. Okay, we try number 4. That's number 3. Whoops, that's wrong. I'll fix it. I'm doing that. Now, for those of you for the advanced course, you should remember that the components should add up, right? This left should equal this right, and the ups should add up to the bottom. Add it up. That's it. That's the advanced course. Don't worry about it too much. What I just said was gibberish, gibberish, gibberish. Just it's gibberish. Kimber, what do you got for number 5? All right. Let me try number 6. Should be rolling. Should be fast. Should be like, oh, this is so easy. Mr. Redley, love this. Let's make it. Let's have a whole test on just this. That would be great. I'm ready. A rock sitting on the ground. Mr. Green, rock sitting on the ground. What do you got for me?
So the force of weight coming from the center, and then an equal force normal coming from the bottom.
From the bottom, going up, should be the same length. You got forces?
No.
Done. All right, let me try number 7, which is going to start us down a whole nother journey. Yes, force neural pushes from the bottom. Ground pushes you up from where it is. All right, Mr. Cafaretta, Dean, this one's yours.
So it's got the force of weight. Is it still pushing directly down?
Which way does weight pull you?
No.
Okay. Don't ask questions like that. It scares me.
And then we have like a force of tension pushing like northwest.
Okay. Force of tension. Huh. Okay, now let's pause a moment. Is this rock going to be moving? Look at the picture. Is this going to be moving? If it's not going to be moving, can these be the only forces on it? Something's wrong, right? Something needs to be pushing it to the right. Agreed? What's pushing it to the right, sir? Force normal. The ground's going to resist the rock going straight through it, right? Because there's a ground down here, right? So it's going to push this way. It always pushes normal to the surface. So it's always going to be normal surface, perpendicular surface. So if the surface is like this, the force normal is going to be that way. All right. Remember, it looks like fun. This is gone. All right, Eppolito, you got this one then. What do you got? Yep. Line straight down for force of weight. Love it. Two forced normals. Sometimes people don't pick up that's a forced normal caused by the brick, but anything you're trying to pass through is a forced normal. Does that make sense to everybody in the room? You did that well. Is everybody okay with that one? The forced normal pushing that way, the forced normal pushing that way. You're trying to go through the brick, you're trying to go through the ground. Both those provide forced normals. All right, flipping it over, we're going to do something radical. Now things are going to start moving. Well, actually, one thing's going to start moving. Then there are lots of moving. But let's do number 9. Number 9. Polak, you got number 9. Force weight pulling straight down. Force normal. What would that force be? What makes you go downhill? You're skiing. You already got force of weight up there. You already got that in there. Hold on a second. Force of what? Yeah, don't where that book is, take it, burn it, throw the trash can, or something wrong. Oh, one of these? What's the magnitude of the force? That would be how big it is. Bigger question. There's nothing else. So this thing would be accelerating, wouldn't it? You have no friction and you're on the side of a hill and you're sliding. You have no friction. You're going to go faster and faster. That's why you don't have any balancing forces here. This thing is going to get shoved to the right by the ground and pulled down by the earth. So therefore, that's why it goes off and to the right. That's it. That's all that's on it. It's a weird way to think about it, right? You think something's pulling you downhill. It's force of weight. You already got that taken care of. Everybody try number 10. All right, Cassini, when you're ready, give me 10. Force of weight pulling me down. Up, left. Up, left. And where does that apply? Where does that apply? It's going to be applied at the bottom of the rock, because that's where friction's applied. And where's the third force? I should say. What are the other forces on this? Front row is saying force normal. Legit. All right, they can't have force friction without being force normal, so that's a safe bet as it ever had one. Sure. All right, number 12 should be easy, but you got to overthink it.
Did we do 11 yet?
Oh, we did 11? That's 11. No, what did I do? Oh, I did 10. You're right. 10. Let's do 11. Huber, when you're ready, give us 11. Force normal going up. Force weight going down. The force of speed? Yes. I agree with you. Does that mean that it has to be something pushing it? Just because you move it doesn't mean something pushing you, right? So in this case, because there's no friction, what's happening is it's probably trying to make constant speed. Right? Something flipped it to begin with, and that's sliding across the floor at constant speed. Is that okay? Which means its net force has to be what? 0. So therefore, it makes sense. You have a force up and a force down for you. Yeah. Ready, try 12. Don't overthink it. That's your warning. Alice is ready because she knows it's her question because she's been counting carefully. Wait, this much. You're working on 12 for half an hour now. Mr. Solis, when you're ready, tell us how to do number 12.
I just put a narrow down on the force.
Narrow down force and weight. He's correct. 13, Ellis, when you're ready. On 12? We assume there's no air resistance until there's just falling in air. We're just going to say no. Now, there would be air resistance in real land, but it's trivial. So we generally don't draw it.
Wait, but it's flying constant, so when you need one up to
Is it trying to constant velocity? Oh! Oh, totally wrong. Totally bitch, you're wrong. How can you leave me out like that? Is that terminal velocity? What does that mean, sir? It's awesome. It's going constant velocity, which means if air resistance is not negligible, it's actually stopping the guy. So we've got this. He's got a force of weight pulling down. He's traveling at constant velocity. He also has a force of air resistance. What do you want to use for air resistance? That's not really normal. Let's call it AR. FAR. Force of air. We get to make up whatever you want to for subscripts. My bad. Who saved my life on that one? What do you guys save my life on that one? Hayden. Mr. Winter, thank you for saving my life. 13. Let me try 13.
There's force weight going down.
13. I got force of weight going down. Whoops.
Force normal going up. And then
Force of weight going down. Oh, this is terrible.
Force of friction going to the left or
Attached to the bottom. My computer can't update that fast, apparently, today. All right, so force friction to the left. Attached to the bottom. Let's see if we can fool anybody with 12. All right, 14. 14. We're going to neglect air resistance now. We're back to throwing rocks. I know, that seems unright, doesn't it? If you wanted to put it force air resistance, make a little tiny arrows of force air resistance, but we generally think we're going to ignore those. Just force of weight, we're done. You got it. You nailed it. Force of weight, pulling straight down. Oh no, I made the video too long. That's going to kill me.